The final recommended alert of the 5, and there are more alerts that a lot of people are going to configure, and I'll go through some of those and how they might work as well after this, but in terms of the top 5, the 5th one is Replica. And this is a statistic that we've mentioned in the past. I believe the example we had earlier gave this about 30 hours. Now, because you're essentially measuring the difference between the first entry in the op log and the last entry in the op log, the frequency at which you're inserting operations here is going to matter. Because remember, your op log is a capped collection. So there's going to be, as you insert new data in here, the new data goes in here and old data will fall out the bottom. So if you're doing this at a constant rate, you won't see this fluctuate a lot. This 30 hours, for example, will stay at roughly 30 hours. However, if you increase, let's say, to get a 30-hour op log with the amount of op log you have provisioned, you're doing 500 inserts. So 500 inserts per second is giving you 30 hours of op log. If for some reason this doubles and becomes 1,000 inserts per second over time, and that stays that way consistently. I mean, a brief blip will drop this down a little bit, but let's say that it actually stays this way for approximately a day. You've doubled your traffic. Maybe there was a code change that increased the number of writes to the database twofold. You will see this number then drop to till the 15 hours, approximately. Because the amount of space in here doesn't change, so the rate at which you're inserting into here, once it fills up at least, will greatly affect the difference between the first and last operations in there. So it's a good one to alert on, particularly because this 30 hours or this 15 hours, as it is after you double the rate, represents the amount of time that you have to do work on any given replica set member before it will become stale. Remember that the replica sets in general, there needs to be a common point. So let's say you've had a secondary out, you've been upgrading its hard drives, replacing its hard drives, something that's actually going to take some significant amount of time, you've been having some trouble. So this secondary has actually been out of commission for 12 hours. Your primary has continued inserting data into its op log, and their common point is right about here. 12 hours, but you've still got, even with this 15 hours, you've still got another 3-hour window here. So as long as you get it back and functioning somewhere in this window, you'll be fine. However, if it takes 16 hours at this new insertion rate, there is no common point. The common point has fallen out of the database. So common is gone. And the secondary can no longer catch up. So in the good scenario, they find their common point and the secondary begins applying the ops this way. If there is no common point to be found, it cannot, because it does not know what the intervening operations are to get to a good common state, it cannot catch up. So this is key, particularly if you're doing any maintenance, particularly if you have to take any secondary out. You want to have this to be a multiple of whatever your maintenance window is. So let's say you have a maintenance window from midnight to 8 AM. This is your low point in terms of your traffic. This is when you're going to do most of your maintenance. So between midnight and 8 AM, this is when you're going to do work on your secondaries. This is when you're going to have to, if you need to upgrade the disks or you have an outage or anything like that, or you need to put more RAM in them, whatever the case may be, this is when you're going to do it. Or even if you just want to update the database software, this is when you're going to do that maintenance. So with an 8-hour maintenance window, I would generally hedge on the side of, very much the side of caution, and say that you'll want to have 24 hours of op log. So basically multiply your total maintenance window by 3. Things go wrong, and if you've got this long to work on something, 8 hours, that's probably because things take a long time, and you can at least have something take 3 times as long. So you might provision 24 hours of op log. You do your calculation, what's your insert rate, what's your document size, how much does that actually have to be, maybe that's 100 gigs, maybe that's 200 gigs, it very much depends on what your data insertion rate is into a particular replica set. But you provision approximately 24 hours of op log. So what might you set your alert to be here? Well, 24 hours is, you've multiplied your maintenance window by 3. I would certainly want to know if my replica dropped below 16 hours, less than 16 hours. And most definitely I would want to know if it went below 12. That's getting a little bit too close to the total length of the maintenance window. Is 50% extra padding over the 8-hour window, but it's getting a little bit uncomfortable for me in terms of cautious nature as someone with an operations background. So I would set my alerts here, either 2 sets of alerts, a sort of a warning alert and a critical alert, or just go for the critical one at 12 hours. So to go back to our methodology, this replica one is actually one that we've decided does actually have an absolute limit. The 12 hours is where you want it to go, and we want to have more than that. Now, of course, you could always just provision more oplog, have a bigger cushion, etc., and you could adjust then afterwards in terms of your alerts. But let's just say that our previous back of the napkin calculations were true, and that we don't want anything to go below 12 hours. So we've put in our value for the replica time that we don't want to go below, and we can just add that one in here. Save. And as it turns out, 12 hours works out to be that big, giant number in milliseconds. So we have the top 5 sort of covered off, the reasoning behind them, how you might think through setting alerts for each of these 5. Just as an addendum, in terms of the alerts, the eagle-eyed amongst you may have spotted that I actually configured the replica time alert, the last one of the 5 recommended that we did, slightly incorrectly. So I configured it for greater than a particular time rather than less than a particular time. And as it turns out, that particular replica set member has got more than 12 hours of oplog. So let's actually look to see how that went off and what it looks like in MMS. So here we are in our host tab again. You'll notice up here I've got 2 things telling me there's alerts on this group. So let's click into that. Replica time has gone above 432, that big giant thing that basically means 12 hours. And you can see it's alerted more than once, and I alerted for both of them in fact in that replica set. I can acknowledge this forever, 24 hours, maybe I'm doing maintenance, it's going to be done in 6 hours. I could just acknowledge that and actually clear out that alert. And the reason for it, if we click in here, scroll down to replica, as you can see, there's approximately 30 hours of oplog provisioned here, and when I use greater than 12 hours, it automatically set off this alert. So, simple little mistake, but it does have the fortunate effect of showing us what an alert looks like, and in fact, the administrator of this group would have gotten those emails as well, and would have continued to get them for the frequency that we configured for that alert. Just to fix it, we would go into alerts again. Here is our alert in question, and we set it to be below, and there we go. We can now clear out those alerts. In fact, they are now already gone. Go into all activity because we've looked at them. We can go back in here, go to close alerts. See, agent down was cleared. Go back up to all activity. These alerts are still here, but they're no longer active. So that's the quick repercussions of configuring an alert slightly incorrectly. Gives us a good example of what actually happens when it goes off. Let's do a quiz here on alerts. Which of the following will generate a host down alert? A replica set cannot elect a primary. Secondary in a replica set goes down. MongoDB process monitored by the agent is killed. MMS agent itself is killed. An arbiter in a replica set goes down.